Here's a very short tutorial on how we would find a constant of integration. So we have a function f of x and it passes through a specific point. Given its differentiated function, we are now to find the full original function. So I know that f of x will be equal to the integral of f prime of x with respect to x. That is the integral of 3x squared minus 4x, and then remembering that the nice way to do this is to write this as single powers of x all on one line. This is going to become minus 2 lots of x to the power of minus 2 with respect to x. Now I work through term by term, increase the power and divide through by the new indice and stick the old coefficient in top. I increase the power, I divide through by the new power, and I stick the old coefficient on top. I increase the power, I divide through by the power, and I stick the old coefficient on top. And remember that I get a constant of integration. Now, before I go any further, I'm just going to tidy this up and say that 3 over 3 is 1, so that becomes x cubed. This becomes 2x squared, and here, being careful because I've got minus 2 divided by minus 1, which would make this plus 2x to the power of minus 1 plus constant of integration. Now what do I know? I know it passes through the point 1, 4, that is to say that f of 1 is 4. So this is the key information that I use now to say if I evaluate this function at 1, I get 4. So 4 should be 1 cubed minus 2 lots of 1 squared plus 2 over 1 plus my constant. And what does that give me? That gives me 4 is equal to 1 minus 2 plus 2 plus constant, which is 4 is equal to 1 plus constant, or the constant is 3. Now I can write out the final function, which is f of x, which will be x cubed minus 2x squared plus 2 over x plus 3. And that's how we find a constant of integration.